Okay, and how do you decide? Now you mentioned deep learning. Previously you said vision-based, cognitive-based systems. How do you decide which one to use?
Well, so I think it depends on the problem. Okay, maybe we'll talk later, but I'm a very much big proponent of deep learning, deep reinforcement learning, also what we call now deep reinforcement meta learning. And those approaches are all data driven, right? It can be also physics informed, but generally the idea is that you have a bunch of data, a lot of data, and then you want to infer information from the data. In the case of, so if you have enough data, you can train a system, right, to autonomously perform certain tasks, which could be exactly the follow-up idea. However, in this case, we have a lot of knowledge from scientists, right? But we don't have, at this point, a lot of data to train on. Okay, I mean, we do have different data from the minor planet centers, right? But it will take, in our opinion, at this point, it will take quite a bit, to create proper data sets that can eventually inform. So we're working informed deep neural networks to do the job. It's not impossible. We took a little bit different approach simply because we leverage on the fact that we have an investigation team that's been working on this for a while, and then now, and usually when you work with scientists, planetary scientists or asteroid scientists, or NEO scientists, they usually would like to understand what is happening and why you get certain answer, and so that's important for the community, right? And in this specific problem, a cognitive system works better because also they are explanatory. So if I reach a conclusion, I can also provide the system can also provide an explanation of why you reached that conclusion. Deep learning systems do not do it. They work on the data and autonomously learn information from the data, but the knowledge is distributed across the weights of the networks. They might be more powerful, but they might not fit they might have a disadvantage in a situation where scientists are currently interested in understanding exactly why I'm getting that answer. Again, there was a choice that was made based on the fact that our team has experience both in deep learning and cognitive systems, right? I found that whenever you work with planetary scientists and space mission exploration, where science or anything like planetary defense is in the is the central team, the science team plays a major role, and explanation plays a major role as well. Therefore, this system, I think, are better suited to interact and with so it's very much a blending of domain experts in the realm of computer science or computer engineering and planetary science, which might fit very well for the case being.
So both cognitive-based systems and meta learning are based on the same philosophy that since you don't have a lot of data, you want to use already the knowledge of the way which you learn from data to build something even more abstract.
Right.
Is the physics-informed method similar, if this is true?
Well, so we have to make a clear marked distinction, and the distinction is the fact that even if you work, so first of all, what is meta learning? So you mentioned deep learning. I mentioned deep learning. We also mentioned meta learning, right? Or meta deep learning. So meta learning is a little bit of different concepts. Meta learning literally means learning to learn. So you want a system that not only learn the task that you want, but also learn how to learn other things. And usually those systems are trained on distributed set of tasks. But from each task, he learns, he accumulates experience, and then eventually he can adapt quickly to new coming tasks. So as a result, you have much less data needed to train these things. Okay, that's the principle behind it. Nevertheless, it's still data driven.
Okay,
and it's still unexplanatory, right? So the only thing is that the meta learning learns mimic a little bit the learning process in humans, where we don't need tons of data and tons of iteration to learn something. We learn very quickly, and the reason is because we probably learn on many tasks, and we take with us the experience that we learn on other things before, right? The cognitive system needs less data simply because it incorporates knowledge extracted from the domain scientist. So what it means that basically I have to elicit knowledge, which eventually to the scientist too, we went through pretty much interviewing. I would call it interview, but it's been an open discussion with planetary scientists that tell me how the process of inferring, which one is best versus the other goes. And so it's an interactive process where you work with the scientists to elicit their knowledge and try to put it in a cognitive system that does the inference as the scientists do.
And they never see data, these systems. I mean, when they're ready, they don't need to.
When they're ready, no, it's another interesting thing, an interesting flavor. There are different flavors here because things, to a certain degree, at a certain point becomes hybrid. Depends how you design this. At the beginning, no, you don't need data. But nevertheless, when we have a plan to do test and validation, so for example, build our own internal simulator tools where we can run simulates observation of many asteroids, right? With known parameters, right? And given these known parameters, if you give it to a scientist, he will tell you, I think this is most likely to be better than the other, or to be more important than the other, or this is the probability that I think that's more likely to be, dangerous than the other. And we want to compare, we do cross-validation in the sense that the system will need to reach the same conclusion than the scientists do, right? If not, you have to tune internally some parameters, right? Some weights or some inference parameters that play so that the two things are matched. However, if you have some data, even limited, in this case you don't need it, you can also tune the system based on data that maybe are labeled by the scientist. That's another possibility that we're also exploring. In this case, you can still train the system, but the training happens to train in the sense that you train the parameters that are behind the inference systems as defined by the scientist. Okay. It's an hybrid approach.
And will it keep the transparency of the system?
It still keeps the transparency because nevertheless it gives an explanation if you tune it.
Okay.
Right? And then it's very interactive because you have to cross-validate with what happens with the answer that the systems do. Mm-hmm. Indeed, basically, one thing that we did is, we made up some 100 objects, right? And somebody gave me out of the 100, we put something like 990 random objects, right? Random NEOs with certain characteristics and so on. And then, embedding this, scientists gave me 10 dangerous ones. And they told me, this is what I think is the most dangerous. And then see if the system picked them up out of it. And it turns out they did, right? After some tuning, we had to do some tuning because the beginning, the explanation didn't seem to be consistent for a couple of those. Most of them was, a couple of those were not. And then we started looking at that, why is this system thinking that they're not important? So it turns out that eventually when you account for the fact that maybe the ground system was able to see it, right? Mm-hmm. It will give them lower priority versus others that instead were not seen by the ground but seen by the spacecraft, because we waited on the way we gave the system to inference that usually it's better to give highest priority to objects that cannot be seen by any ground assets, but they're only identified by the spacecraft. So, as you see, that's a kind of a process of validation. And then we had to tune it, a few things. So it's kind of an iterative process to go. So the other one is completely data-driven, but for a deep learning to work, we'll need a lot of data. At this point, it doesn't seem to be the best way to approach that. As we say, we have time to develop this, so we're in the testing phase. We are in the development phase now. So.